better. I've got a son who's 9 months old, and it's easier for childcare to look after my son, you know, when I'm not having to go to the office every day. So it's cool. Hello, Imran, you're okay?
Yes, I'm doing pretty well. How about you?
Hello, Imran.
Good, all good.
Just FYI, Salman will be like 15 minutes late. He's stuck in traffic, so but Rich will be taking the lead in the
Yeah. We'll just give it a few more minutes and let a couple more people join.
Yep.
And then we'll get cracking.
How's the data pre-processing going along for you?
I think quite well at the minute. I spoke to Sam and I just didn't want to do too much without everyone's input, if you know what I mean. So there was a couple of decisions in terms of the encoding, because one of our features has 60 classes, and obviously that's going to be an absolute nightmare if we try and encode that. So I'm just trying to open the floor up to discussion on what we can do to tackle that problem. I've made a couple of notes and a couple of insights which I'm going to share with the group. You know, once they're all here, and I think, you know, if anyone else has got any better suggestions, you know, we could go with that. But I think it's a task that we can overcome. It just there's a couple of ways of doing it.
I know some of the participants also. Sorry, go ahead, Tim.
I said also the category may be changed in the future, so we cannot make some category fixed because we don't know how if any new category pops up and or it's not identified. So we maybe think about this issue also, how in the future the model will work.
Yeah. That's the wonderful world of ML ops. It's one thing building a model, but then it's maintaining it when someone sends in data that just doesn't compute. That's the beauty of it. Building the model is only like 1% of the job. Maintaining it's the rest. But yeah, there's certain things we can do on that. But I think for the data that we've got, which is static, thank God. There's a couple of techniques we can do to get around having a lot of categorical classes. But yeah, I hope, you know, I'll share a couple of ideas and hope, you know, open it up for discussion. We've got 14 participants now. Do you wanna go ahead, Imran?
Let's wait for 2 more minutes. Usually I notice they come in like the first 5 minutes after.
Cool.
One thing that I noticed looking over the data that we might consider is that there's a lot of features in this data set that are in a way duplicated within other existing features that are provided. So like all of the minimum and maximum temperatures for each month are fundamentally exist within the cooling and heating degree days calculations, as are all of the days below and days above certain temperatures, because of the range that heating degree days and cooling degree days are set up. So it's heating degree days is above 65 and cooling degree, or vice versa. So like that's 44 features that are essentially encoded elsewhere. So like we're adding 60 features by doing a one hot encode on the facility type one, but we might consider dropping 44 features elsewhere, essentially, I think.
Yeah, definitely. That is something I observed as well. And I think when we get to the feature engineering, I think that it might be a good idea to group certain features. And on the initial, when I was looking at the data initially, I thought we do have the average temperatures for each month. And it might have been a good idea to group these average temperatures by season in 3-month quarters, if you know what I mean. But you know, it's hard to tell right now, just because, you know, it'll be good making them decisions should come after feature engineering. We can see the importance of them, and then based on that, we can see if we can get any stronger features by combining them or splitting them out. But yeah, Michael, that was if we can drop features that are already sort of present in certain calculations, it would be better, because a simple model is always better. for a number of reasons. So yeah, it is a good observation.
Let's wait for a minute and then get started. Rich, so today is mostly like you guys just share your code and then we all will comment and you tell what's your logic.
Yep. Could you just enable sharing?
Yes.
It won't let me share my screen.
Rich, I have a question. Actually, I posted in this posted in Slack also. So why you have used Knn imputation technique for only 2 columns, and is it the best possible approach to treat null values for numerical columns instead of mean imputation technique?
Because that imputer it looks at the relationships between features, and we sort of thought that the age of the building and its energy efficiency will be sort of inherently linked. So using that, the imputer sort of calculates the distance between these features and comes up with a value that meets them all, and then replaces the missing values with them. And I think it did quite a good job. However, I have made notes saying that it made our energy star rating a bit more variable, which I'll show you in a second. The second part to your question was, is it the best possible approach? It's hard to say. It might have not been. But it takes a lot of computational power as well. But we'll have to compare it to another form of imputing, which I use the simple imputer for the rest of the data. If the variation in the energy star rating that the KNN imputer caused becomes an issue with the model, we can always go back and revise that and use the simple imputer for maybe the most frequent and see how that affects performance. But I'll tell you what, let me share my screen anyway and we can talk about them parts.
Yeah, thank you.
Give me 1 second. There we go. Should be better. There we go. Right, can everyone see that now?
Yes.
Yeah.
Okay. So, Salman.
Sorry to bother. Do you mind starting from the scratch or from the beginning?
Yeah, from the beginning. Yeah, of course. Yeah.
And also, before you start, I would like to emphasize, if anybody who have concerns anywhere, please stop and ask. We all are here to learn, so there's nothing to just. Please don't shy. Just ask. We all are learning. So, yes, you can go ahead now.
So, the first part of the data pre-processing is basically importing your dependencies. So these are all the libraries that we're going to use for data manipulation. You've got NumPy and Pandas, so we can deal with, obviously mathematical computations and tabular data. The data visualizations there, which Salman labeled well. Matplotlib and Seaborn, and also missing number, which you'll see in a moment. And then the feature selection tools and encodes, that is related to a part further down into the feature selection part, but we'll ignore that for now. First cell reading the data. We use Pandas to bring in the data and take a look at the head, so we can just get a good glimpse of what data we're dealing with at the minute, and also the names of all the columns. Obviously, you can check these kind of things in Excel as well, but it's probably better to put it all into one notebook just for ease of understandability. The test set was also loaded, but we don't do anything with the test set in the first instance, because we don't want us, our models to see any of the test data. It needs to be trained and tested within the training set, and then once we've created a model, that's when we bring in the test data. Which, bringing it in now, it doesn't make any sort of difference at all. It's good to bring it in anyway, so we can take a look at that and see what, is everything coherent, and is everything where it needs to be. Because obviously we're gonna have to do some processing, the same processing we did for the training data. We need to do it on the test. Obviously, you can see there's a number of missing values and whatnot, so it'll be the same process, but we can put that to a pipeline, which we can go into later on. We looked at the shape. So this is just a summary statistic of how many observations there are and how many columns. So in the training set, there are just over 75,000 observations and 64 features, including our target variable, which is the site EUI. The next part, train info, that is looking at sort of what sort of data is stored. So we've got int 64, objects, and float 64. So you've got your integers and floats, and objects will be your what is it? Categories. Your categories. Yeah, that's the one. The word, the word popped out my head. So as you can see, we've got 3 object columns. We've got 24 float columns and 37 integer columns. Now, just before I go on to this part, when we're going to scale our features, we're going to have to look real hard at the integers and the floats. From initial sort of observations, our numbers are quite in the same sort of region of scale, but things like the floor area, they are very, very large numbers, and regression algorithms, they will take the size of our values into consideration when trying to making predictions and reading our data. So we'll have to come up with some sort of scale for the floor area. There's a number of ways we can do that, which I'll get into later, but that's just a consideration there. We checked the null columns, so we could see a percentage of what column, how many missing values were in each column. And we did quite, we had a significant amount in each column. Year built was only 2%, but the rest, like the energy start rate, it's quite significant. These ones are sensor. These were picked up by a sensor. So the reason for this could be the sensors weren't working. Maybe the sites didn't all have these particular sensors, but it's something that we can't solve. Basically, this is just missing data. It's not random. It's just, there's a number of reasons why. Okay. We extracted the list of them and we visualized it. Sometimes it's a little bit easier to see what we're dealing with by visualizing it, and this is visualized using the missing number package. And someone in the chat also mentioned you can do it on Seaborn with the heat map as well, which that is very useful. But I think for purposes, the missing number package was designed to do this sort of thing, and it gives a good, probably more intuitive look on missing figures. The descriptive statistics, this gives us a chance to look at the outliers, and sort of what kind of scale our values are in. So if you can see, the smallest number in the minimum column, what we're dealing with, and the highest number we're dealing with in every particular column. And then you can see the particular percentiles there, the mean and standard deviation, and also the counts as well. You can make sure the counts are pretty much coherent. Obviously the ones with the missing numbers will have a different count, but yeah, we can pretty much see we're all in good form. Duplicate entries, there was no duplicates. And that, when we say duplicates in this sort of sense, it's rows, not values contained within the columns. It's if there's any sort of rows that are duplicated, they're probably the first. If you do find any, they're probably the first to go after investigation. It could be an error, but more often than not, it shouldn't be there, and so that, you know, we can drop them. But fortunately enough for us, there was none. Unique values, we can see this helps us sort of understand our categories first and foremost. So building class had 2 categories, year factor had 6, state factor had 7, and so on and so forth. So that the biggest sort of ones there are like your floor area. As I say, it's a very heavy feature of the data set in terms of both scale and the amount of unique values in there as well. The IDs, you'll see later on, I actually put the ID as the index, only because this doesn't necessarily give us any sort of information about the building. It's not a sort of predictive feature. It's just simply tagging each single observation. So that's why I set that as the index. Okay, there was a data frame created with the null values. And you know, these are the this just made it a bit more easier to visualize the null values. As you can see in this part here, this was the these were all the you have to separate the categorical and the numerical features. This also, if you're doing any sort of visualization or any sort of pre-processing, sometimes it is easier to separate them out. You don't have to. I don't usually do it, but you know, a lot of people do it. And because I usually just do it with the whole data frame and move the columns around as I see fit, based on what the features contain. So this is the first sort of part of visualizing the data explanation. So what I did was do a count of the categorical data. So it wrote a little function called draw plot. And what it basically does, it pulls all together the categorical sets that were separated before, and it just counts them and puts them in a graph. So what we can see here, there's 2 building, there's a number of the states, and you can see that state 6 has the largest amount of observations in our data set. Onto the building class, we've got 2 building classes, residential being the higher amount, and the commercial being a second to that. And then this was a very interesting one. This was your facility type. So as you can see, the vast majority of our observations in the data set fall within the multifamily uncategorized, followed by the office uncategorized. And I did a little calculation, which we'll discuss earlier on. So the top 10 of these particular classes account for 87% of our observations. Now, I'll speak about this a bit later, but this is an observation that might come in handy on when we're at the encoding stage. Okay, and now this was is there any questions about that initial sort of breakdown in data processing? Did everyone understand the things that Salman and I did and why we did them?
Yeah, got it.
Okay. Thank you very much. Now, this is the most recent part of is the data imputing. The first one is the Knn imputation. As I said before, this sort of calculates the distance between 2 features and basically predicts what the best value will be based on these distance metrics. I've included some information about the Knn. This is the documentation from scikit-learn, and then this one is a more mathematical breakdown of how it actually works under the hood. I don't know if anyone was interested in that, but that's, you know, I've updated that to include it because it is quite fascinating.
Thanks for sharing.
You're into them. Yeah, it is important. You know, it's one of the, you don't have to know exactly what goes on under the hood you don't have to write your own Knn imputation, but it's a good idea to know how it works and what the processing is behind it. It'll make the understanding a lot easier. So what I did here was basically check the distribution of our two variables, and the first one was the year built and the second was the Energy Star rating. Because if you have because it measures the distance between features, it does the KNN imputer does take into account the scale of the value. So if you have a very large number in there, or a wild scale where it ranges quite wildly, it will affect its predictions. But when I checked visually, it seemed that we had a sort of coherent sort of shape to each of these features. So on initial thoughts, I didn't really think scaling was necessary at this point. So I extracted these two columns. I fit and transformed using the KNN imputer, selecting 5 nearest neighbors. So when we say 5 nearest neighbors, to simply put it, it sort of groups, it tries to check 5 different points and comes up based on these 5 different points and with their position in a 2D space. It decides on a value based on that. 5 is the sort of default. I believe it's the default setting. It may be 3. I'll have to double check that, but 5 is usually a good place to start when doing these things. It can be changed. It can be it can be any number you want. But there is 5 is just a common place to start on that, and especially for this task, it was set against. It was a good. It's a good number to start at. So I fit it and transformed it, and what that basically means is that I fit it to them particular columns, and when you do the transformation, that's when you engage the KNN algorithm on that. So what I did then was it takes the 2 columns and it turns them into a NumPy array. And so what I had to do was basically add these to a list, the results of the imputation to a list, and check that list if there was any null value. So we got 0 and 0. So that means every single missing value was filled with a prediction from the KNN. So then I plot the results of our test to see how it affected the distribution of our figures. The year build test seemed it actually uniformed them quite nicely. You can see compared to the previous graph, there was a couple of higher bars there, but it seemed to level them off. So we've got quite a nice clean year built column there. But as you know, if you looked at this before, what you'd notice here, this is a bit more, well, this is a lot more variable than we had originally. Now, variance in sort of regression tasks isn't necessarily a good thing. So this is a feature that I would like to keep my eye on when we get to the feature engineering section, because it might be it might make the model a little bit less ineffective. So we could go back and scale the Energy Star rating before we put the KNN imputer on it, or we could just use a different sort of imputation, like the simple imputer that I used on the rest of the data sets, which I'll show you in a minute. But this is definitely one to keep an eye on. And I've also put an example code there. Did someone say something then?
I have a question,
Yep.
maybe the same repeating one. So can you please explain again, like the deciding factor for KNN imputation over mean imputation? Like how did you choose it and why?
It was only because someone did suggest it in the chat, and I thought it was something I never thought of. But I think we used it is because the year date, the year of the building being built, and the Energy Star rating, intuitively those 2 features will be inherently connected. Older buildings, or there's different, older buildings may not be as sort of optimized for heat leaving them or entering and things like that. So that was sort of an intuitive look on that. It might have been wrong, and in this case, from looking at our data, it has created a lot of unpredictability within the Energy Star rating. So I think, depending on on what we find in the feature engineering, I think this may have to be amended. But I don't know yet. We'll have to see. But the reason for choosing the KNN imputer was simply because the two columns we put it on are sort of inherently linked. That was the only reason.
What I was looking at means I was analyzing, and I figured one thing out, that since in the year column there are only 2% or 2.8% values missing, we can get rid of those rows, and that would be fine, because year, I believe it is a very good correlation with the EUID, the target, which means if we get it wrong, that would make the model biased. And since we are only losing 2% of the rows, since we have 87,000 about 86K data, that means if we are losing just 1,800 rows, that should be fine.
Absolutely.
So that would be one strategy for year. And KNN is a good strategy because it does not take care of the mean or something like that. Means somebody suggested last time, and it was pretty amazing because I never used it previously. And so that was amazing because it looks in the neighborhood, and based on the neighborhood, what exactly the values it looks in the neighborhood, it just impute with that particular value. So that's amazing. And in terms of the scaling, we can always, if there is some sort of skewness in the data or something like that, we can always try different type of scaling, like log scaling or something like that. So we can always do that. So which we are going to do. So exploratory data analysis, the next step in which we will kind of like look into that. And that is amazing that you guys are bringing up the ideas. So that's amazing. Yeah. So I have some stuff as well. So when Rich is done with his description, I will show you something as well. Means I found something very amazing. Only 3 lines of code can give you complete introductory EDA in a very visualized manner. So I will show you that. Yeah.
Perfect.
Quick question before we move on from the KNN thing real quick. I've used KNN to actually create like a model in silly things, but I haven't used it in this way before. It seems strange to me that we did both. So we're saying that the rating and the year built are intrinsically linked, but when you did this, you calculated them both at the same time. Like you're fitting. I don't know
so you're confusing yourself. Knn Imputer and Knn model are 2 different things. So this one is kind of like looking in the neighborhood and figuring out what other variables of that particular relative means. It looks in the data and it looks around that particular variable that you want to impute, and looks around the variable that what are the values for other variables, and based on that it picks up one value.
Right. But we're picking up 2 values at the same time, and we're saying that one of them, Energy Star rating, is intrinsically linked to year built. So wouldn't we need to have that data filled in? Like, wouldn't we need to impute year built first so that we have that in order to do a better job of imputing Energy Star rating afterward, essentially?
Yeah, it's fit on the 2 columns because it sort of goes through them columns and checks the corresponding sort of values on each of the columns. And then based on what it's learned from them columns, it will then make a prediction when it comes across an empty value, if you know what I mean. So I fit it on both the columns because it needs to you can fit it on the entire data set and it reads all the data set, but it takes a long time. But because we were only using it for the 2 columns, it was only cross-referencing each figure with both the columns. So it would look at, if there was an Energy Star rating missing, it would look at whatever the particular year was aligned with that, and then say, well, what else is there in there? If it's from 1957, the nearest neighborhoods around it may be around 60 Energy Star rating, so it put it in there, if you know what I mean. That's how it works through. It's slightly different to a KNN model in terms of clustering, but it still uses that sort of nearest neighbor kind of thing. Because it was only looking at them 2 columns, it cross references them both.
Okay, understood.
And that's a good point, Michael. Because what we can do is we can impute after dropping the rows for the year, and then we can impute and we can see if there is a change in the energy star rating or something like that. Yep, that's a good point.
Yeah, that's right. That was something that, dropping the year built empty values, because it is only 2%, that wouldn't have been such a bad idea. But I think, for demonstration purposes, it was probably the best way forward to impute them, just to see what we can do with it. But yeah, in a sort of real life sort of scenario, if there's only like less than 2% of the data is missing of a particular column, yeah, it will be fine to drop them. So yeah, I'll get to the end of this and then we can all discuss the last sort of stages. So yeah, what I did here, because I created 2 test columns to make sure, to not override our existing data, I made 2 test columns to put all the results in there. And when I was happy with them, I moved them back into place and dropped the original columns. So that's where here, the energy star rating. So yeah, they were then input as all the imputed values were then put into the columns and back to where they belonged. But as I say, we can change that if we need to, if like the energy star rating variability affects our model. So just to double check that worked, the process above worked, I just done a little is null sum on them 2 columns, and yeah, the correct columns were replaced. So the rest of the data, I used the SkyKit, I don't know why I put learn there, but it should be simple imputer, only because, as we mentioned in the chat, the vast majority of the like that direction of wind speed and things like that, that wasn't computed and it was missing. So it was, and to be honest, I don't think it's a very compelling piece of information in them particular columns. So I think a scikit-learn simple imputer was the best way to go, and I put it on the most frequent, which means it just replaces the missing values with the ones that appear most in the list. There are other options, but I don't like, in terms of the mean and median and the constants, I don't think there's enough variability in the information that actually was there to use them. So the most frequent I thought was the best option. If you think different, let's try it. It was just my initial thoughts and I went with it. So as you can see, I pulled the columns and it's a very similar function to the KNN implementation. I mean, so bring in the class, you call it the missing values. So they're the values that you want to be replaced in real life data sets. There might be like things like question marks and that need to be replaced. So you can convert them to NP nans, or you could simply put a question mark there. But because our value is completely missing, I could put NP, which is numpy nan, and it would look for the ones that had no value at all and replace them with the most frequent, hence the strategy. I fit it to the training data and then transformed it under the trained imputed. As that made it a NumPy array, I had to convert it back into a data frame. So I did that there by making it trained imputed, and the columns were the list of columns that I saved up here before doing the imputation, and then rebuilt the pandas data frame as you see it. Okay, and then I ran a check on the is null values, and yep, it worked perfectly. There was none at all, so I was very happy with that. And I just double checked that with a missing number matrix too. Now, the data encoding, I'll run through it quickly because I'm just conscious of time. Here I set the index to for the ID, just because going forward that's probably the best bet. Now, the reason that we have to encode is basically, other than sort of NLP algorithms, the machine learning algorithms tend to use numbers, numerical values. So we have to change our sort of objects, strings and whatnot into numerical values. As you can see, we've got 7 unique values in the state factor. Building class has 2 unique values and facility type has 60 unique values. So the easiest one to tackle first was the buildings class, and I could just use the pandas built-in function get dummies. And what get dummies does is basically give you a binary option. So we had a, what was it, a 0, what was it, a 0 for residential and 1 for commercial. And what it does is build that at the end of, and as you can see, building class commercial is a 1, building class residential is a 0. Now, there's a problem called a dummy variable trap, and that means because you can tell whether or, you can tell if something's residential based on another features value. So, what will happen because of that? A machine learning algorithm will be biased and pick up a lot of bias on that. So you have to drop one of these. So obviously, if it's going to be a 1 here and a 0, we obviously know it's going to be commercial. If it's a 0, we know it's going to be residential. So one of these is not required, and it'll make our model a lot more efficient if we drop it. I've put a little link there just to read more up on about dummy variables and what this means to data sets. It happens, it happens a lot. And so when you do one-hot encoding or any encoding whatsoever, make sure you're well understood on the dummy variable trap. It'll make your life a lot easier.
Yeah, I would want to say something. Yes, absolutely right. This trap, so it's kind of like, for example, like if in your data set you have male and female in one particular column and you want to encode it, and you would get 2 columns. Wherever it is male, it will say 1. Wherever it is female in the other column, it would say 1 for female. So we know that if it is 1 in the male column, that means it should be the 0 in the female column. So we can drop the female column and we can just stick with 1 column. That would reduce the dimension as well and complexity and things like that. So one-hot encoding and dummy variables, the pandas, they do exactly the same thing. The only thing that happens is in the dummy variable, you have the option to drop first. So so you can drop first column. We'll wait for everybody.
Sorry, I got totally engrossed in the explanation that I forgot. So I was really enjoying the presentation.
I don't believe I was talking for 40 minutes. It didn't feel like that.
Yes, that was amazing. Yeah.
Good job, guys.
So what I was talking about, I was talking about the that one-hot encoding and dummy variable do exactly the same thing. The only thing dummy variable gives you, it gives you another option to drop first in the same line of code, and that is the only thing. Otherwise, if you use one-hot encoding from the scikit-learn, you would have to do one extra step to drop that particular column. But dummy variables kind of like save you that. So they are kind of like same. And you had something else, Rich? If you finish, then I will do my part. Yeah.
Yeah, the only other thing I was going to say is once I've come now, we completely understand now that a 1 indicates a commercial property and a 0 indicates a residential property. Now that's fine. It was an easy one to do. Use get dummies. It's it's very easy. Now we're on to the one-hot encoding now, which is we didn't want to use a label encoder. Only because Michael mentioned that it could cause issues with weighting because it would sort of order the categories by number, and we want to avoid that. It'll skew our results. So we were going to one-hot encode. So that brought us to the facility type, 60 different classes. Now, there's 2 ways we can handle this, and we can go for only use the top 10 of the facility types, because the top 10 account for just under 90% of our observations, or we could use all of them but group the facility types.
That's what I was thinking.
Yeah, we may only have 10 of them, but we group a lot of them together just to make their influence a little bit more fairer, rather than just having it very heavily towards the multifamily and uncategorized, because that could skew and make the model biased as well. So I would, before doing anything on that, I would have just liked to open the floor and just to see if anyone has any, does anyone agree with using the top 10 or grouping them, or does anyone have any other ideas at all that we can implement to get around this issue?
I have an idea. I have an idea. I will say that then everybody can take their. So what I was thinking is, since one of the variable is kind of like 60-70% of the rest of the thing, what we can do is we can just make two categories. One is that particular variable and all of them grouped together in the other category. And that way we would have, because we don't have enough number of rows which are representing that particular category in our data set. So which means that way we can kind of like just go by the biggest category and all the other categories merged together. So if it is this or that, this way we can save it. That is one way to go. But the other thing is grouping. That is what the second thing I was thinking about.
Yeah, I like that idea. As I said, if we let's just stop. Let me just do a quick little bit of calculation here. So yes. You know what, we could do that actually, because if we group the rest of the categories together, there is 36,000 observations, while the multifamily uncategorized group is 39,000 observations. So that pretty much splits it almost 50-50.
Yes,
that would be interesting.
Imran, if you let me share my screen, I want to show the graphs which kind of like support that. Yeah,
I just did.
Okay. So what I was telling you about was these three lines of code. These three lines of code can give you all the information that I'm going to show you here. So what it does is it basically do the complete EDA on all the variables automatically with these three lines of code. What I did is I basically just installed the Sweet Whiz. In fact, this is not the three lines of code. The three lines of code are these. So you need to install SweetWhiz library and then import SweetWhiz as a S3 variable. I imported it. Then I just analyze report. I'm just initiating a name for the HTML file. So what it does is it creates an HTML file. So this sv.analyze, and then I put my variable. Train was my data frame. So I just put in the data frame. Then what it did is basically just created an HTML file. And then this next line of code is calling the HTML file to display it in the Jupyter Lab. So I don't want it to be displayed anywhere else or outside the Jupyter Lab. So it just displayed it over here. So now you can see every single variable, the distribution. It is telling you how many distinct variables are. It tells you total number of values are overall. It is telling you what is the distribution of the data, total RAM usage, features, categorical, numerical, everything is kind of like done here. Then if you look, so everything is kind of like displayed here. For example, we were talking about facility type. You can see this facility type, multifamily and categorized, it is more than 50%. And the rest of the others are pretty much low. So what we can do is instead of making two categories, we can maybe make so anything below 10% we can put them together in one category, and anything above 10 we can make a category of its own. For example, like office and categorized can be one category. All the others we can combine them with education, class, lodging, hotel, all these three. So we can make total of three categories, because those three categories would be kind of like giving you a good idea. Or the other thing. So that's one thing. And floor area, if you look at the floor area, you can see the floor area is kind of like the maximum value is 6.4 M, but the minimum value is 0. So that means there is a lot of variation. So we need to take a look at this particular thing as well. Year built is something we can convert year built into the age of the building, because year build gives you a big number, 19 something. We can just convert it into age. We can just subtract the year built with the 2022, and we can find the age of the building. And based on that, that would be a good variable to deal with instead of using the year. And since we are dropping 2%, you can see the number of zeros are less than 1% over here. So it is telling you that the number of zeros are this much, but we need to find some NaN values as well, which we are going to see. Energy star rating, a good distribution, elevation, things like that. Next thing, what I wanted to talk about, there are a few variables at the end that you see over here, like the wind ones. This is everything is generated with 3 lines of code. So maximum wind speed. So this maximum wind speed, you can see that there are only 16 distinct values, and majority of them are 1. Means majority of them are 1, and only few values which are either 345, 360, or something else, which means we need to be very careful about this variable as well. But we identified that there are a lot of missing values in this particular variable as well, since it has a lot, I think around 60% missing values. It's better we can just drop it, but if we are not dropping it, this is a good idea that we need to be careful about the categories that we are dealing with here, because majority of the values, more than 80% values, or around 80% values, are just 1. And only few variables values are kind of like different. We can just convert it into categories, like when the wind was at level 1 or level 2 or level 3 is just 3 categories or 4 categories, which kind of like sum it up for this particular variable. Because when I did the feature engineering, so I did some sort of feature engineering as well, using light GBM, so, and recursive feature engineering. So what I did is, where is it? It is here. So for feature selection, what I did is I used light gradient boosting machine. So light gradient boosting machine, it's a simple gradient boosting. It looks for the smallest gradient, and since it is kind of like pretty fast, it is developed by Microsoft. And you can check this particular link here. It takes you to their hub, and it tells you that how many winning competitions, means how many competitions recently have been won by light GPM. So it tells you that it is a very, 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 very amazing kind of like fast, efficient version of XGB. So XGB, yes, it is good, but it is kind of like computationally way heavy than light GBM. So light GBM kind of like is also used to select features as well, just like, since it is an ensemble method, just like random forest, it kind of like gives you now which features it got selected, and it gives you a rating of every single feature, and then we can use that to look at which features are good. Yes, Imran?
Well, you guys are showing some really cool stuff. Definitely, I'm totally engrossed in this. My only concern, I just realized right now, there are some beginners as well in the pool, and I'm afraid we have shared a lot of stuff that's like a feature engineering supposed to come in 3rd week. So I'm afraid they will not be able to handle that much. So maybe we should. I'm okay, right, but people are okay for us. That's right. I'm really enjoying it. I'm just worried they don't think that way, or should we?
We will do the whole week for feature engineering, but just to get the idea of which variables are important. Yes, I'm just explaining. Even if somebody is beginner, I'm just explaining that this kind of like gives you, and if they want to keep this code kind of like works in every situation for me. I just change the variable names and it works. So just copy it somewhere, and you can use it when you have so many features to deal with. Just put it up and put your data frame in it, and it's going to give you the rating of which feature you should look at. They are important and everything. So it gives you a first-hand insight into the data, because there are a lot of variables. We are spending a lot of time on several variables, 60 variables. So there should be some sort of a shortcut. So this is a shortcut which kind of like gives you a quick which variables you need to be looking at more closely as compared to the others. So I'm just giving an overview. Yes, we will go in detail about this particular thing.
So Salman, will you be sharing it in the GitHub?
Roshni?
This piece of code that you are explaining right now, will you push it to GitHub?
It is on GitHub. It is on GitHub. The first thing that I posted, it is in that particular file. So I did that. The first thing I started analyzing this particular data. That is the first thing I did.
Oh, okay. Amazing. Thank you.
Yeah.
I was just going to say, Varun has mentioned how are we thinking of grouping the different types of building, because they are split into 2 different types. We've got commercial and residential. So I think when we look at the commercial and residential building classes, they are quite similar. If you know, one's about 30,000 observations, the other's about 40,000 observations. So I wonder if just splitting the facility types down by that particular number might be even more efficient. Or, as you said, Salman, do we go with having maybe 4 groups based on your visuals in this here.
So
the ones,
this
the ones
facility
you've got
type,
there.
I think there should be 3, means office category, multifamily category, and other category. Because you can see it has kind of like accumulated all of the remaining other, because there are 60 of them. So it is just displaying the top 5. So what it did is basically added all of them. So we can add this education class, or if we want to go by these 5 categories, that should be fine as well. Because these are major categories. So it is still showing you the top 4 major, and then rest of the others are combined. So we can stick with that.
Yeah, I think, I think that will be a good idea. I would stick with that. Cool. That's a good idea. Yeah. Does anyone else have any input at all? Or what do you think about this particular idea?
Sounds good.
But more importantly, who wants to code it?
Any questions, everyone? Feel free to ask. This suite-based thing, by the way, looks pretty cool. I never knew about it.
Yeah.
I just kind of like was exploring around, and there's another which Komal kind of like shared with me. So when I said that I have 3 lines of code and it will display, so she asked me, "Are you using something?" Which one was that, Komal? You want to share?
See, if I would have knew about this would make my life a lot easier. I just didn't know about it.
Yes. So it gives you first time just 3 lines of code, and that's it. Sorry, you were saying something?
I think he was talking about pandas profiling. I just heard about it. I haven't implemented. That also is like 1-liner code. It'll give everything in a HTML file.
Yes, pandas profiling. So it also does the same thing.
Yeah, pandas profiling. Yeah.
What do you guys suggest? Let's say, okay, it looks great so far what you guys just presented. I'm also thinking there are people with different backgrounds, with different experience, and they might have something also which is also valuable in addition to that. What do we do? What do you guys just say that how they can also share, so at least we can modify our sheets or maybe add that or incorporate that also, so then they also think they're engaged?
I'm not sure if Komal already worked on it. I mean, I worked with Komal offline on a different project where profiling was implemented. So I don't know if she got the chance to work on it. I myself am currently learning how things work here. I haven't worked very extensively on Python. I only know basics, not as much as her. But I don't see that she's joined.
Sorry, I was talking on mute. Actually, I tried to run the profiling libraries, but I was having some missing package issue. I'm trying to figure that out. I'm not sure. I'm not able to handle that thing. Maybe I'll talk to Rich and Salman. Yeah, once that is solved, I can add that. Run it and then show it.
I think the easiest way to do that is. Oh, go on. Sorry. I was just going to say, if you're using like Jupyter Notebook or anything like that, I use Google Colab because the vast majority of Python libraries are already installed on there, so you don't have to do that. It's only very sort of niche libraries that you have to install, and for what we're doing, Google Collaboratory has all the packages, so it would be worth getting a Google account and signing up to it. And it's completely for free as well.
Rich, I was using a Jupyter Notebook, but I tried to run it in Colab once.
Didn't it work in Colab?
No, I will try now. Like
you're gonna try? Sorry. Yeah. It's just an easy way, and as it's free, the only limitations is that you've only got a certain amount of space you can upload. I mean, it's 60 gigabytes or something, so it's not as if you're going to need a pretty big CSV file to go over that. But it is really good, and it's fast as well, and you can use Google's GPUs and TPUs as well to if you're doing anything quite intensive. So yeah, if everyone can get onto Google Colab, it'll make your life a lot easier.
Yes, definitely. Just to remind, we have a meeting. Sorry.
Yes, one thing I want to add. So far, we have not done few things. For example, like we have not checked for outliers. We have not gotten rid of them. So that is what we are going to do next. So anybody who wants to get into that, so these particular files are on GitHub. So go on GitHub, just pull request or clone them, or clone the repo or something, and then open it wherever you want to open it, Google Colab or Jupyter Lab or something, and then try to put in your code in wherever you feel you want to explore in particular category. Just explore. This is something outliers. We haven't looked at them. Kind of like just plot some box plots or violent plots or something, which gives you kind of like overview of the distribution of the data, along with the kind of what box plots does. Violent plot kind of like does extra one thing, which it gives you the box plot, but as well as it gives you the distribution along with that. But it is computationally extensive since we have a lot of variables. Just stick with box plot, see which outliers, what should be the strategy for getting rid of outliers. There are so many different strategies. So we can work on that. So anybody wants to step in and do something in this particular phase of the project, outlier is something we haven't touched. So yeah.
Yeah.
So since we allocated each week for each task, so what I think might be helpful, that whatever, so it's great that we made so much progress. It's good that we are like way ahead than what we're supposed to. One thing I think will be helpful, since considering the people's background, since some are beginner, for whatever is designated for first week, we just go in depth, inside out, like whatever is needed, just finish, including that outlier thing. So at least by on Wednesday, we should have that also completed. So at least we know we covered all 360 degrees of that before, because EDA has a designated week. So it's great that we have done so much EDAs, but that has a week. So let's do what we are supposed to finish by Wednesday.
Sounds good.
And also, I would like to add, it would be great if we add comments like Salman was showing facility type. We'll add five columns additionally why you are doing it. I mean, it would be helpful for beginner like us to understand later at some point if.
Yes, I think we are adding them. If you have any questions about them, means I think we are adding a lot of theories. For example, like when Rich was showing, he was using the links, he was giving you the links, extra links, he was writing his stuff. So yes, we will try our best, and we will try to put some links out there as well, so that you can go and further explore that particular thing. But I think we both are writing our analysis, that what we are doing and why we are doing, and what we are kind of like getting inference from that particular thing. So yes, that's a good thing. We will keep that in mind. But we are doing it. If you go and check it out.
Yeah, thank you.
Yeah, good job on commenting, guys. I definitely have to give you guys good credit, as well as you guys have commented well, as well as you guys given us the link as well. So anybody want to go in depth, they can go. So definitely, it's very, very, very structured. This collab thing, so I know anybody can go and should check. I highly encourage everyone to, especially those who are beginners, they should watch the videos later on, because I can understand there's a lot to absorb. And feel free to ask in the group. There are 3 task channels, so feel free to ask them directly as well, those questions if you have. Nobody gonna judge here. Any questions?
Yes.
The GitHub link you have shared in the chat, it's not working for me. Just page not found.
So it
might be, you might have to be invited to it. I think it's a private Git.
So I invited at least twice or thrice already. So check your spam. I know some people had issue, but then when they
actually I did try to accept the invitation, but it kept showing me that the page not found. Like that happened twice already.
Okay, good. So I mean, not good in that sense. Why don't whoever has issues with GitHub still message me privately, so at least I'll just resend the link and let's see if we can resolve that. Because I know some people had this issue, but they found in their spam and it worked fine. So I'll try it again.
Sure. Thank you.
No worries. Any other questions, anyone? Let's see if I have anything in my agenda. Well, if not, so feel free to ask if you guys have any. Try to watch, especially beginner. I'm going to upload the video. I've already uploaded the last lectures video as well on project management folder. And I highly suggest you should watch it. And if you have still concern, feel free to message task leads in that channels, and I assume all of you should have added the task 1, 2, 3 channels as well. And That's pretty much it from my end, at least. Anybody else, any questions? Otherwise, let's just wrap up.
No, I was going to say, Salman, do you want me to do the grouping of the columns and you can just take a look at the outliers? Or, yeah, is that fine? Cool. And then what I'll do is, once I'm done, I'll upload. I'll upload it over my version 1 again, and then once you're done, Salman, you upload your version, and then we'll make a version 2, and that will pretty much be the final version. Then, and we can rename it final before we move on to the EDA
Yes.
section.
For the GitHub, Rich, there's a folder SRC. In that, there's a task1 folder, so we have to put all our files over there. So yeah.
So for next presentation, please, can you guys coordinate and then put a finalized version on Wednesday, and then go over to that finalized version of that pre-processing task next week on Wednesday. Okay, thanks guys. Thank you very much. Great job.
I'm having one question. Can I ask?
Yes, please.
Yeah, the question is, like, in this data set we have lot of rows, but there are few problems for which data sets are very small. So what we can do in that case?
Do you mean like the variance of the data is very small?
No, like number of rows are very small. If you search for data sets for 3D printing, you'll find very few. And the one which you are finding, they are hardly having 50 to 60 rows in that.
I'm not sure about understanding your question. Are you talking about like what we can do for other data sets in terms of what we're doing now?
Yeah, the question is that if there are less rows in data set, how we can continue with those type of data set?
Well, to be fair, it's the stuff that we're doing now. You can apply it to any data set. The steps that you take to get a clean data set, it entirely depends on the data you've got. Some data sets are very clean. If you work in an organization which has a very good sort of data and analytics team, a lot of the data sets you don't need to even do much with them because they're already being processed. However, if you're collecting your own data from various different sources, that's when you'd have to clean them. But the steps that we're doing can be pretty much applied to any data set. The code will have to be changed just based on the interpretation of another data set.
Okay, so like in this session, are we going to deal any data set where number of rows are very less?
No, because we're only going to be using the data set that's assigned. This is going to be a data set that we're going to be using for the next 2 months, the 2 4-week periods. So this is the only data set that we'll be using. But if you can try our code out on other data sets if you modify it.
Okay, thank you.
All right, everyone. Let's just wrap up this today. Feel free to message co-leads if there's any questions. Sorry, go ahead.
Yeah. Can I ask a thing?
Yes.
Yeah. So for now, we are going to work on the train and see test files on the data folders in GitHub, right?
Yes.
Okay.
So for this one, we're just using train for now mainly. Train and test. Yes, these are the two for yes.
Okay. Thanks, man.
Oh, no worries.
Any more questions? Just give me a shout.
Yes.
So let's say we have a column where there are it's a categorical column. It has 2 values, let's say 1 and 0, but the number of rows with the label 1 is higher compared to 0, like let's say 90% and 10%. So how do you balance that? Like, would you remove the entire column, or you would treat it in such a way that it's still useful?
Sorry, asking Rich.
Sorry, it broke up for me. I got a bit of lag. I didn't hear the question. I already heard it was about deleting a row.
Can you repeat again?
No, let's say we have a column and the column is a categorical column and contains two variables, one, let's say true or false. And the number of rows that are true is like 90%, and the number of rows with false values are just 10%. So there's an imbalance, right? So how do you treat this particular column, or would you remove it completely? What would be your way of approaching this?
If it was 90%, one particular value and 10% the other, it would entirely depend on how important that feature was. So initially I would leave it alone, and then when I got to the sort of feature engineering, I needed to check the importance of the columns. I would see how the weighting of them two particular classes within that column measured against model performance, and then based on that test do something about it. Now the things you could do, you could drop it. It might make your model a lot too biased, or there may be, if you've got like sort of industry knowledge about the data set, there might be a way of dividing it up into equal chunks to see how that happens. It just depends on the sort of context of the data, but if it's just as like a classification or a binary 1 and 0, and 90% were 1s and 10% was 0, it would literally be down to just checking how that performs in a feature weighting operation, which we're going to go into in week 3. That's when we're going to handle them sort of problems. But yeah, it's hard to say without a context to the data, if that makes sense.
Got it. Thank you.
Cool.
Okay. Thanks everyone.
Right.
Let's see you guys all
I'll
on
see you
Wednesday.
soon.
Thanks a lot, Rich.
Thank you.
Great job today.
Thank you.
No worries.
Great
Bye
job.
bye.
Bye bye.
Thank you.